This is called a conditional equation. The reason why it's called a conditional equation is because you actually get an answer when you solve it. I would give you guys time to solve this right now. In fact, if you're watching a video on this, press pause, solve it on your own, and then see if you can do it. There's a bunch of different ways you guys can solve this. An algebra teacher teaching this for the first time, unfortunately, would tell you some steps. And they would say, you have to get rid of the parentheses first. There's other ways to do it, but it's actually easier if you do the parentheses first. So to do that, you would distribute the 6 and the 3. So you go 6 times that, and 3 times that, and that. And so you get something like this. 6x minus 6 plus 4 equals 21x plus 3. And then you want to get the x all alone by himself. And to do that, let's see, I'm going to subtract 6 from both sides, or 6x, so that those will cancel out because they'll equal 0. And let's see, on the right side we'll have, I'm going to show all my steps here for you guys. Well, hopefully all of them. I'm gonna simplify these ones so I don't have to write it twice. So that's gonna be -2. You guys with me still? And so now all the x's are on the right side, which is cool. That means I don't want the 3 over here. Using inverse operations. See that says plus 3, so now I'm going -3. I have -5 right here equals 15x. And here we have, just want to pause for a moment. We have equivalent equations. This equation right here is equivalent to that one, and this equation right here is equivalent to that one, and this equation right here is equivalent to that one. And we're getting them by doing inverse operations. Whatever you do to one side, you have to do the other side. That's how you get equivalent equations. What's the last thing I gotta do? Divide by 15. I don't want red anymore. I want purple. So I divide by 15. I get 1x. We don't write the 1 though. He's a ninja. And don't forget to divide the other side by 15. You get -1/3 after you simplify. So that is your answer. Like I said before, there's other ways to do this. Some of you guys might have thought, raise your hand if you thought this, because I'm curious. Some of you guys might have thought to divide by 3 first. Anybody think that? Anybody? Oh, yeah, see? Okay, so if you divide it by 3 first, that's correct, just as long as you do it correctly. This is harder to teach though, so teachers normally don't show you guys this stuff. Alright, so I have 3 times 7x plus 1. You can divide both sides by 3. If you do that, then you're going to get 7x plus 1, because the 3 divided by 3 is a 1, and it cancels out. And right here, on this side, you have to take the numerator and divide each of those terms by 3. So you're going to take this term and divide it by 3. That's going to be 2x minus 1. And you have to take this term and divide it by 3. So that's going to be plus 4 over 3. Now right now some of you guys might be thinking, there's no way this way works. It does. Check it out. What do you guys want to do next? Someone tell me, because there's... Distribute to 2? Okay, I'll do that way. Alright, so we distribute to 2, so now we have 2x minus 2 plus 4 over 3 equals 7x plus 1. Let's get rid of this 2x and move it to the other side. So now we have, we would subtract the 2x, so it's 5x plus 1. And on this side we have a -2 plus 4 over 3. Whew. So if I change this, it would be over 1, and then I'd make it into a 3, which would make that into a -6. So I have -6 plus positive 4. Wait, am I doing it? You guys good? Oh, wait. Hold on. I'm going to check my work now because you guys are asking me questions. That's right. I multiply the top and the bottom by 3, and then I get -6 plus 4, which would be a -2. So I have a -2, and the denominator stays the same. -2. All reminders. You guys are just getting off summer break going, what the heck's going on? Alright. I'm going to subtract 1 from both sides. Subtract 1. Now that 1 I'm going to change to have a denominator of 3, so it's -3 over 3. What is a -2 minus 3? -5 over 3. This equals 5x. The last thing I want to do is divide by 5, which will give me just x, 1x, which is what we want. But not to divide this thing by 5. But that's kind of weird, having a fraction inside of a fraction. You guys remember how to do this? I know you guys learned it. -5 over 3 divided by 5. Remember how you would change this into a fraction, and then you would change it into multiplication by the reciprocal? Whoops. Yeah? Yeah. And you cross cancel the 5s, so you divide them both by 5. Oh, snap! Oh, snap! What the? Right? Come on. That's cool. Isn't that beautiful? Appreciate is totally a lot of extra work. That's why you would normally get rid of do the distribution in the beginning, just like I did with the purple stuff. Okay? Alright, let's check out the next one I want to show you. Okay, now this is, I made this mistake first period, so you guys got to fix it. This is a negative x over 3, and this is a negative x over 3. I'm going to show you guys a contradiction equation and an identity equation. They're pretty similar in what happens. In fact, these two equations are pretty similar. Alright, let's do the first one. For the first one, all these fractions. How many of you guys hate fractions? Yeah, everybody hates fractions. Don't hate fractions. Trust me, they're way better than decimals. Now, if you want to get rid of fractions, you want to be a fraction killer, you can manipulate this equation so that the fractions are no more. And the way you do that is by multiplying everything by the common denominator. What's the common denominator for a denominator of 3, 4, and 12? Yes, so if you multiply everything by 12, your fractions will go away. If no one taught you this before, I feel bad for you. Okay, I got an idea. I'm going to show all my work. So I have negative 12x over 3 plus, so I went 12 over 1 times this. You guys see how I got negative 12x over 3? I hope so, because I got to move on. So now I have, the next one's going to be 36x over 4 equals, now 12 times 2 is 24. I'm not going to do the fraction version of that. And then 12 times this guy is going to be 60x, over 12. Now there are shortcuts that you can take right here in simplifying, but this is the way to do it to, explain it to you guys. Now I simplify everything. When I simplify this one, what do I get? What's negative 12 divided by 3? Negative 4. And then I get 12x. No, that's not 12. That's 9x equals 24 plus 5x. I simplify the left side, I get 5x equals 24 plus 5x. And then I subtract 5x from both sides, and then you all gasp. You go, "Urgh." Why? Because our x's went away, and we have an untrue statement. 0 does not equal 24, therefore we have a contradiction. This is no solution.
Well, I'm weird too.
Stop it. Stop it. Alright, we're going to do the same thing for the identity equation. We're going to multiply everything by 12. I'm going to put the 12 over 1. But I'm going to kind of copy the work that we already did because a lot of it's the same. See, we have a 12 times x over 3. We did that over there. Okay, so this is going to be negative 4x. Right? That's what we got right here. And then the next one's going to be positive 9x. That's because that's what we got right here. It's just skipping steps, trying to save a little bit of time. But then we have this one right here. This is the only thing that's different from the other equation. It has an additional plus 2 right there. So that means I have a plus 24 equals 24 plus 5x. Okay, so this is almost identical to this, except we have an additional 24 because of the plus 2. Now, I'm going to solve stuff. I'll simplify this. And you guys should notice something right now. Both sides are exactly the same. Hence the phrase identity, because they're both the same. Now, if you continue to solve this, you're eventually going to, like when I say continue to solve, if you continue to use inverse operations, you're going to eventually get down to 0 equals 0. And this is all, the solution here is all real numbers. Or you can say all real numbers. Well, I mean, this is technically the set of real numbers. But yeah. Alright, so let's look at one more equation before this one's over. Oh, rational equations. Oh, how I love thee. Alright, what I'm going to do here is we're going to find common denominators for everything. Because it makes life a lot better whenever you work with rational expressions and you have common denominators. Alright, so in order to do that, you want to look at every denominator and factor them all. Now these first two you can't factor. You can only factor this one. But you're thankful because that's a difference of squares. It's x plus 2 and x minus 2. That's what you get when you factor it. If you're stuck on that, I can help you on that later. So now you look at your other denominators. Let's take this first denominator for example. This one has an x minus 2. So does this one. But this one also has an x plus 2. So what do I have to do to this denominator so that they're the same denominators? Multiply by what? Yes. So I multiply the top by x plus 2. And do the same thing with your other fraction. You multiply the bottom by x minus 2. And then you're going to have to multiply the top by x minus 2. So let's write out what we have now. On the left side we have x plus 2 over x squared minus 4. I went ahead and simplified it. On the other side we distribute this 3 right here. So we have 3x minus 6 over x squared minus 4 minus 6x over x squared minus 4. Now I don't like subtraction signs when I do work with rational expressions, and so I change them to addition, and I take the opposite of the numerator. The numerator that is right after the subtraction sign. So that's going to be a negative 6x. I made it negative because this was subtraction, but I changed it to addition. Okay. Now, all the denominators are the same. We can kill these fractions the same way that we did before, by multiplying everything by x squared minus 4. Because the common denominator is x squared minus 4, right? Except this time, let's just take the shortcut and cross them all out. So now we have x plus 2 equals 3x minus 6 plus negative 6x. That's just the numerator right here. And you solve it. And when I solve this, let's see. I'm going to go kind of fast now. Negative 3x minus 6. On this side we have x plus 2. Move the x over so I have negative 4x. What? Did I do something wrong? No, that's right. And then I have minus 6 and 2. Put the 6 over there so I have 8 equals negative 4x. X equals negative 2. Now that is supposedly the answer. But whenever we have rational expressions, you must check for extraneous solutions. What are extraneous solutions? Well, there's one major rule for fractions. What can fractions not have? Yes, a 0 on the denominator. You can't have it. Why? Because you can't divide by 0. That's against the rules. And it's just not possible. You can't divide by 0. Not possible. So, if I plug negative 2 into these x's, will I get a 0 on the bottom of any of them? Yeah. Yes, this one right here, I'll get a 0 on the bottom. So, this is an extraneous solution, which means there are no solutions.